Hey, Sammy. Just feel free to join on the stage. Cool.
Hi, can you hear me?
Yep, I can hear you. How are you?
Perfect. I'm doing great. Thank you, Brandon. How are you?
I'm doing all right. Just going through the motions, hosting the hackathon, hoping everyone's having a good time. But yeah, feel free to start whenever you're ready.
Okay. Let me just check a few things here. My presentation is ready. Sharing.
And one more thing, are you okay with us recording this and then posting it on to our YouTube later to make sure that if anyone missed it, they can watch it?
Okay, no problem.
Sounds good. Thank you.
Perfect. So I guess you can see my screen now. Yes.
Yep, can see it.
Okay. Should we wait for a few minutes so that some more people be able to join, or can we just start right away?
Yeah, feel free to start.
Okay, perfect. So, hi everyone. Thanks for being here and for listening to me. I'm Sammy. I'm the CTO of Eden AI. We'll share for you more detail about what we do at Eden AI a little later on in this presentation. I'm in France right now, in Lyon, and it's 5 a.m. here. So, sorry if I don't have the same level of energy as you guys, but I will try and do my best here. All right, let's start then. So, I'm gonna start with a very general question about what AI is, and I'm not gonna bring a satisfactory answer, I guess, because actually for defining artificial intelligence, you need to define intelligence. And if you look that up on the internet, you will find tens of different definitions. And the one that is going to be, I guess, most repeated is that we're defining intelligence as the capability of doing human-like tasks, as we're defining ourselves as being intelligent. So artificial intelligence is the the discipline of trying to make robots or artificial beings behave like a human being. And now, when we're talking about artificial intelligence nowadays, we're mostly referring to neural networks, because that's actually the technique, I guess, that made artificial intelligence what it is right now. And so that's based on a simple idea that everything in the world is a math function that we're trying to approximate. So we suppose that there is a mathematical function that takes an image as an input and produces as an output a description of the content of the image. And at the same time, there is another function, and it shouldn't have given them the same name, I guess, where it takes text as an input and produces an image as an output. And we're gonna try and approximate these functions. So if you guys have done some maths, you must have seen some function approximation techniques. And the idea is that whenever the function gets more complicated, you need to add more parameters to approximate it. And that's the same idea with neural networks. There is a theorem that says that neural networks, if you give them enough parameters, they could approximate any function in the world, and that includes the function that takes an image and turns it into a description, and the other way around. So with that being said, neural networks don't have 1, 2, 10, or few hundred parameters. They have now billions of parameters, and that makes them actually very powerful at doing very complicated tasks like handling language, English language, for example. And the difference between like a billion parameter and 175 billion parameters, like for the GPT evolution, is like the difference between 31 years and 5,000 years. So I like giving that example to show how much we are trying to add parameters when defining these new models. And ChatGPT is one of the large models that are out there. They are called large language models. It's not alone. There are other models that we don't speak about that much because they are still it's kind of closed. They are not open to the public as has GPT been with ChatGPT. But yeah, a lot of companies are trying to build bigger and bigger models to handle more and more complicated language tasks, for instance, or image tasks, etc. And so usually you're gonna when if you try all these different models, you can find some models that are open source, others that are accessible through APIs like ChatGPT. If you find some kind of weird output when dealing with a model, it might be because it's just trying to predict next word, sorry, from your input. So let's say a basic large language model. If you say is in the input, what is the capital of France? It's just gonna predict related sentences like what is the France largest city, what is France population, etc. But with language models that are trained to follow instructions like ChatGPT, then you will have more interesting output, like the answer to that question. So the capital of France is Paris. So beware of that. If you have a language model that's producing kind of bizarre text in reply to a response, maybe that means it's just a basic model that was not trained to follow your instruction. And yes, the most interesting models are the ones who are following instructions, and that's the ones we are going to talk about today. So the idea of the talk, I didn't actually present that clearly enough until now, but let me go back. So the talk is called Towards More Reliable Usage of Generative AI, and the idea is for you guys to try and play with generative models, not just to generate funny outputs and put screenshots on your LinkedIn or your social media about funny feedbacks or funny responses you get, but actually trying to make something out of these generative AIs and use them in your workflows, in your softwares, or in production, etc. So that being said, one of the first steps is to try and understand how we can talk with these models and how we can make them do what we want. So there is a kind of I don't know if you can call this engineering. You're gonna find prompt engineering showing up on different articles, etc. But yeah, I guess it's debatable whether it's engineering, but at least you will have some guidelines that you could follow to get some interesting outputs and reliable more reliable outputs out of your generative AIs. So we can talk about large language models like ChatGPT, but also generative AI in general, like for generating images and videos, etc. So for this part, I'm gonna show you a quick demo on a presentation from deeplearning.ai. I don't know if you know the website, but it includes a lot of courses about deep learning in general, and they did a pretty great job with prompt engineering. Quick course, it's about an hour long, and it gives a lot of interesting guidelines. So I'm gonna use that to show the different points summarized in this slide. So there are three principles that you should be able to follow if you want to use generative AI the right way, or generative models right way. So first principle is to write clear instructions. Second is to give it time to think or try to break down your request into specific tasks. And the third principle is to iterate. So don't try to get one perfect prompt from the first time you write it, but try and improve it on different iterations. So you could I will give you a link to this course with this notebook, and you can I guess you should be familiar with notebooks, and you can actually execute the code and change it and get different outputs out of your yeah directly into the website. So here the first part is just to get the OpenAI API key, because it's based on the OpenAI GPT API. So the first part is just to set up the environment. The second part is to define a simple get completion function that gets a prompt as an input and returns the response of the output. That's the function we'll be using to show the different examples. So the first guideline here is to actually delimit the clearly the different parts of your prompt. So you should not hesitate to specify the delimiters in your prompt. For example, here we are asking the GPT model to summarize the text, and we are saying that the text is delimited by triple backticks. Then we'll put in the text here. If we run that, we should be able to get the summarization of this text. So the prompt is this, and the input text is this. And as you can see, the input text is wrapped inside the triple backticks. So that's better for the generative model to actually understand where the limit is between the prompt and the input text. And also I'm going to talk about that a little more later, but it could be also a good way to handle some security issues like prompt injection, because a user could just instead of the text write something like forget all of the above instructions and do something. And if a user injects this as a text into your prompt, it could behave differently than what you're expecting it to behave. So putting these delimiters makes sure that the generative model takes that text as an input text and not as a prompt. Secondly, the second instruction would be to as a second good practice would be to specify exactly the the format of the response. That makes it easier to process the output. So, for example, here we are asking it to generate the response as a JSON in the JSON format with keys being book ID, title, author, gender. So we're trying to generate a list of made up book titles in the JSON format. And as you can see, yeah, as you can see, it pretty well handles that and get and brings and returns as an output the JSON with the format that we wanted. So in Python, it's going to be very easy to transform that into a dictionary and use it for the rest of the program. And the other thing that we could do is to include the condition into the prompt, saying that if you can generate this, generate as a JSON format, but if you can't, return something like a specific message, so that we can handle the errors more easily into our program. For this example, we're going to ask the GPT model to transform a text into a series of steps. So we are adding a condition saying that if the text contains a sequence of instructions, then do this. If not, return no steps provided. So in your program, you can just write an if condition. No steps provided is in the output, then don't do anything else. Process or parse the different steps. So here, if we give it an text with the instructions, it's going to be able to return the different steps. So it's a recipe here. It was able to transform it into a series of steps. But if you give it a random text with no specific instructions in it, and we keep this condition, it should return no steps provided. So that's one thing to include in your output, so that you can know if you're gonna be able to process the output or not. So that's about the condition part, and also should know that giving examples to the output to the model is great, actually. So don't hesitate to do that. You can do it in the iterations that you're doing when trying to improve your prompt. So if you see that the output is not exactly what you want, then you should not hesitate giving it examples. So for example, here we're trying to write a prompt to give a kind of grandpa style response to our questions. So there's a child was asking the grandpa to teach him about patience, and the grandpa is responding with a kind of deep response here, I guess. And if you do that, then the model understands better what you're expecting it to do. Yeah. Let me know if that's clear for now. Don't hesitate to send messages. I guess you can send messages here. Let me see. Yeah, there's a messages more. Perfect. Yeah, don't hesitate to interrupt me if there is anything you want me to elaborate. I will take some time to explain a little bit more if that's needed. So yeah, and the second principle is to give the model time to think. Said otherwise, the best thing to handle complicated tasks is to guide the model into the way of resolving those tasks. So, for example, instead of let's see here. Yeah, instead of saying like, here's the text and please output the names from this text in English, output the names that are specified in the text and the French translation of the text. You should give it more detailed instruction, like for example, summarize the text and then translate it into French, and then list the names, and then output everything into a JSON format. So in this way, the handling the task becomes easier for the model, and it makes the output more easy to generate. Let's see. Yeah, so here we get exactly the response we want, with the text summarized in French, and the fact that the text is talking about two different individuals, and that's kind of a complicated output given the text to be generated directly. So given these different steps make it easier for the model to generate the response. I hope that's okay for everyone up until now. If I don't get questions, I'm gonna assume that we are understanding everything I'm saying. So great, smart people. So there are a few things to keep in mind while doing this. First thing is to be aware of possibility of getting prompt injections into your software if you're including a kind of generative model capabilities. So given those delimiters or just keeping that in mind can give you sorry, just keeping that in mind is important for you to be able to handle that in your software. For all the examples I just showed, I always try it on one example. All the prompts I showed were tested in one example with one example, sorry. And that's not good because you can't just assume that because one example worked, it's going to work for everything else or any other example. So you really need to try your prompts with a lot of examples, some tens of examples, or ideally hundreds of examples, to be sure that the prompts work well and generalize as well to different types of data or different other texts, etc. And generative models being statistical models, you can never be 100% sure that the output is good or reliable or safe. So should keep that in mind and know that there is a delta of risk that you need to handle, or the users could have to handle at some point. So so for now, generative models are models that need human validation. And actually they have some issues that make them a little more complicated to use in production than other technologies. So I've written a small article about why some companies or organizations are buying actual ChatGPT, and that could be companies or schools or any other type of organizations. So some of the concerns are data safety concerns, because even if I think a few days ago, OpenAI gave made a new create a new option in, I don't know if ChatGPT or all their open or if it's in all their APIs, but you can specify that you don't want their models to train on your data. So I'm not sure if that's enough, but I don't think there is anything that proves that everything or all your data that are going into a large language model, a proprietary large language model like GPT, are not going to be used or not going to be discovered by someone else. So we in Europe we have what's called the GDPR. So it's a regulation regarding the safety of the data, and for now these type of models are not following the regulations, I guess. Also, when generating text, there is a possibility that the text could have been somewhere else on the web, and you should not just assume that it's an original text that belongs to you, because that's still not 100% clear. And you should also keep in mind that the models do have problem of what we call the hallucination. It means that sometimes they generate false information. A large language model is not that smart. It doesn't know it's when it's actually generating real information or false information. I could give you an example of that. Let's see. Yeah, if I go back to sorry, to the lab, there is an example that's provided here. So if you ask it to tell you about a fictive product that doesn't exist, here it's a smart toothbrush that just does not exist. Then it's gonna, let's see what's gonna do. Yeah, so it's gonna generate a description of the Aeroglide toothbrush that just doesn't exist. Based on its name, it's gonna generate false information, because because it doesn't know if that's a real product or not. So it's just gonna follow the instructions and generate the information you asked it. So you should keep that in mind. And there is article from Hussein Mehana, comparing or doing a parallel between AI or large language models and the automated or the automation in the car industry. So in the car industry, you have levels of automation going from 1 to 5. So level 1 automatic car just gives you just basic options like a cruise control. That's something that now every car has. Level 2 gives you like partial automation, like automatic braking or park assistance, etc. That's also kind of a mainstream option. Level 3, you start getting some environmental awareness capabilities. So you can actually let the car kind of drive at some extent, but you always need a human driver to be able to take over if anything happens. That some vehicles do have that option also. But that's even less. It's less common than the two other levels. Level 4 is something that we don't have for now, but it's a full self-driving car mode where you just point out point A and point B and be sure that everything is gonna go well, and just trust your car into doing that without having to intervene, so you can sleep in your car while it drives you. And that's something that is not achieved for now. And level 5 would be a car that's gonna just that doesn't need any input from the user. It's going to be 100% independent of the user, giving it inputs about anything on the travel part. So for now, the large language models are kind of level 3 models, but they can have some autonomy, but always need a human to validate what they are doing. So yeah, so we are not we are very far from AGI or something exceptionally smart at this moment. And the only real models that are actually tested in production with a kind of large level of automation of independence, sorry, are specialized models that have made their that are proved to be reliable, and you have a lot of providers on the out there creating very specific models for translation, for example, or detecting objects in images, or detecting uh, uh, defaults in some parts of an image, translating text, etc., or doing speech recognition, etc. Those are specialized models that are really trained into one specific task and can't do anything else other than that task. And for the moment, if you want to put something in production, you should first think about those models before trying a general model like a language model. So I've written small articles about comparing the performances of a language model that was GPT-3 at the time, with different specialized model in some specific tasks like extracting keywords, analyzing sentiment of a text, um, and translating text. And you can see that specialized model, even if the general language models that can handle multiple tasks do pretty good. So this is the case of GPT-3. I guess GPT-4 would do even better here. But the specialized model from Amazon, Google, IBM, for example, still outperform the language models in all these different tasks. So it could be language detection, sentiment analysis, keyword extraction, or translation. And you can find everything about the tests here. So the data set I used, the evaluation metrics, and the scores. So you can try it yourself if you want. But yeah, for the moment, the best choice is still to use a specialized model for the different specific tasks that you could need. But if you need text generation related tasks like summarization, transforming the text, or expanding it, then OpenAI is, sorry, not OpenAI, but language models or large language models are the best way to go. So if you are facing a problem that you want to address with AI, you should ask yourself, is there a specific model that could handle that specific task, a specialized model for that task or not? If there is one, you should think about using that before trying to solve it with generative model. Also, you could use some level of validation using these specialized models when uh, creating pipelines with generative models. So, for example, if you are generating an image, you can check if the objects you are wanting to generate, you want to generate are is or are displayed in the image with the object detection model. You can also check if the image does not contain any explicit content. So you can add that validation layer. And image generation models are very bad with text for now. So if you don't want image generated with like gibberish, you should try and run OCR to extract the text and see if it makes sense, or ideally there should be no text actually. So could run OCR if there is a text, rerun the generation to get another image without text. Same thing with the text generation. You can check for NER is named entity recognition, and it's the task of extracting the named entities, aka the persons, the organizations, the products, etc. If you want the text to talk about the product, for example, you can run NER to see if the product is really mentioned. You can use text moderation to see if there is no explicit content there also. Sentiment analysis to see if the text is not aggressive or something like that. And plagiarism detection to see if the text was not copy pasted from another source. And we can do that using Eden AI. Let me show you that very fast. So yeah, I can talk about Eden AI now. So what we are actually building is a unique platform that regroups all the best AI APIs in the market. So as I showed you on the previous slide, you have hundreds or even maybe thousands of different companies working on very specific AI models that you could use to create really great softwares or automations. But you need to be aware of what they are doing, and that's not easy at all. So what we wanted to do is to actually make all the AI innovation available for everyone by bringing all these solutions in one place for our users. So it's a kind of super AI provider that we are building here that has all the capabilities of all the different providers available in the market. So if you go to the website, then you'll see that you could do a lot of things from text processing to speech processing, text to speech, document processing, translation, image or video analysis. And so for text processing, if you want to text modulation, you can find, for example, Microsoft or OpenAI. If you want to do another task like speech recognition, then you will find a lot of different providers out there that you could use. And each one has its own price, so you can balance between the price and the performance to choose the best to optimize the cost performance ratio. Same thing for image. If you want to detect associated content in images, you can find different providers that have different models that you could try. And for our task, sorry, we're gonna need image generation model. So as you can see, it's really easy to use. You can just copy paste the code snippet and should work right away. So the pipeline we're trying to do here is to generate image and see if it contains explicit content or not. To validate the image generation. So I'm gonna use a collab It's a notebook that's hosted in Google, so I'm gonna create a new one. Right. So the first thing that you need to do is to get your API key. Actually, you could use something like this. This is a fake API key. You can just specify your API key like this, but I'm using the get pass so that you guys don't see my API key. So yeah, if you want the API key, you can just copy it from here. If I run this, then I should be able to securely provide my API key. Yes, perfect. Okay, now I have my API key, so I'm gonna go and copy the image generation. Code snippet here. Right here, and replace this with my key. This is a test. If I run this, I should get a response. So here I'm specifying OpenAI as a provider, and this is a text as in a prompt, which is not great. And I'm asking it to generate a 512 by 512 resolution image. So let's see. If I get a response here, it should be able to output the response. I'm gonna output just the URL because if I run an example here, then you see here I gave an example photograph of an astronaut riding a horse. Each one of the providers here generated its image, and I can see the API response here as it's structured into a JSON with each image generated in the items list. So I'm not gonna be interested in so the image is base64, but I'm gonna be interested in the URL that's here. I'm gonna click here so that the response should be response stability item and image resource URL. I'm just gonna get that. So items. Zero. Yeah. So I guess the notebook doesn't want to show the binary image. So I just copy. This is the image that was generated. And that's the image I could use for my next steps. So having that, I can define a function that's gonna be called image generation that takes a prompt as an input and returns the URL of the image that's generated. I think I'm gonna use another provider because I prefer Stability AI over OpenAI actually in image generation, but that's a personal preference. So I'm gonna use Stability AI as a provider here, and I'm gonna use it here also to get the response. Is it possible to use mobile? So I didn't see the questions here. What do you think of ChatGPT for being able to evaluate its own output is still requires some user input? Okay, I'm just gonna take a few minutes to answer the questions here. So, yeah, evaluating outputs is good uh, to to make kind of um, more reliable uh, more reliable language models, let's say. But it's still not the right. I don't think it's the right way to evaluate a language model. Automating the evaluation of a language model with a language model uh, could enhance the reliability of it, but I don't think it should be the way to go to evaluate it. So I don't think it replaces the automatic evaluation or validation that you should be able to put in place. Um, so yeah, I wouldn't rely 100% on that. Is it possible to use more in development with internet access when really fact check itself to prevent the hallucination? Fact check For now, all my implementations, all my checking. Uh, so fact checking is kind of complicated task to do, as if you don't do it manually, then it becomes hard. Because if you have a model that automatically checks a fact, that it shouldn't be a shouldn't have we shouldn't have any problem with hallucination at all. So if we are able to do that, then we will have solved the hallucination problem. But since checking facts or checking if information is correct or checking the truth, I guess, in the more larger sense, is complicated even for a human being. So checking that automatically is pretty complicated. I don't think we can do that. There are some techniques where you can see the certainty of the model outputting the generated information, and based on that, say if it's a reliable output or not. But saying for sure that a fact is true or not is, I think, not doable automatically. Will generative model eventually become accurate enough to be used similar to the specialized model? I guess we could actually get closer and closer to a specialized model in simple tasks like sentiment analysis, or maybe even translation. Because with even with few examples, you can see that the the performances actually go higher pretty quickly. So yeah, you can just fine tune a large language model, and they're gonna be very comparable to a specialized model. So yeah, I think if you really go um, a step further in the fine tuning, then we could actually maybe in a few years get rid of specialized models in specific tasks. But uh, um, yeah, it's not the case today, but would happen. Mm, You do have yeah, the question here is, can it be able to describe the image that we provide? So yeah, GPT-4 has the capability to act on different types of data. It could be image, for example, and yeah, it could generate a description for that image. That's something that also all the models, specialized models that do that, but GPT-4 can do that also, even if it's a general model. I don't see other questions, so I'm gonna try and go rapidly over the example here to finish the presentation, because I see that the time is going. Time is running. So yeah, we have
That's
our
no
image
problem. You
generator.
can go up until like 9, so you're good.
Okay. Okay, perfect. All right then. So yeah, here is our image generation function that we wrote in a few seconds. If you want explicit content, we can go into the image part and get our explicit content code here. Copy paste it into the notebook and create our function that takes explicit check, that takes a image URL as an input and put it here. Image URL and generate the response. We can try it. So yeah, we can generate an image here, image generation. Actually, what I like to do also when generating images is to use the text generation to optimize my imagination prompt. That's something that I do every time because I find that AIs talk better to each other than us talking to them. So if I ask a language model to ask an image generation model to output or to create an image, then it gets better results than when I ask it myself. So I'm gonna add here an image generation, a text generation function that's gonna optimize my imagination prompt. Optimize image prompt. So I'm gonna give it a description, and it's going to translate it into a imagination prompt description. So I'm gonna ask it how would I say that? Yeah, generate a detailed image and generate a detailed image generation prompt for this. And I prefer using Cohere here than OpenAI. So here providers are the different AI companies that create different models, and we can use OpenAI or Cohere here. And I prefer Cohere. I'm gonna set temperature a little higher to get to go a little more creative. And you can also specify the models that each company develops. So Cohere develop different models, and I prefer the X large one as it's more accurate. As I said, Cohere here, it should say Cohere here also. The generated text. So this is my imagination prompt. I'm gonna try and generate an image showing a battlefield, something like that. That's as close as I could get from explicit content without shocking you guys. I don't want to do anything shocking here. Image equals prompt for let's say I'm doing something about a war between two military troops. Image. So, yeah, yes. Yeah, so Cohere proposes this prompt with some details about what's going on in the image. And I'm gonna use this image prompt to generate my image here. So, okay, to make it a little more readable, I'm gonna actually copy paste the function here and then the explicit check. So once we have the prompt, we're gonna run it into the image generation and get the URL. Gonna copy the URL, paste it to show you guys what is this. Oh, okay. I didn't put the prompt here, so it generated the random image because the prompt was bad. Now it should generate something war related. Let's go. Yeah, it's not shocking actually, but I wanted it to be a little more. Okay, let's see the explicit content if it validates it or not. So given this URL, sorry, generation URL, image URL equals. We're gonna use another provider here because I know that Google doesn't detect anything weapon related. So yeah, explicit content. If I see the different examples here, I can see that Microsoft detects only Go adults in racy. And Google detects medical school violence, etc. And Peak Purify detects weapon content. I'm gonna see if it detects that there could be kind of weaponry here. So if we use the explicit content from Peak Purify, then yeah, it doesn't detect weapon, and yeah, there are no weapons here. So the image is safe, and we could actually go and print the different explicit content categories levels, and with those levels, validate if the image is usable or not, and yeah, so that's kind of a pipeline that I would use to automatically generate image and, for example, publish it with some kind of validation from a specific model, like an explicit content detection model. I'm gonna put a link also in the presentation with this code to let you guys play with it and try more aggressive prompts and test the explicit content detection yourself. So yeah, I think you have access to the platform and you can try all the different APIs yourself. There's also a GitHub repo with because we open source the aggregation layer, so we standardize in the inputs and the outputs of the different providers, sorry, to make it easier for the users to switch between providers and find the right one for their problem easily. So as you were saying, I was changing providers here without needing to change the code. So if I go with Google here instead of Stability, then I don't need to change anything. Not Google, for example, OpenAI. For image generation, I don't need to change anything else in the code except for the provider name. So that aggregation layer is open source here. I'm gonna put the link here for the GitHub repo.
Yeah,
Don't
and I
hesitate.
can post these on our workshop recaps as well. So all the different links that you need to post, just feel
Yeah.
free to send it to me and I can get that on there.
Perfect.
Yeah, is that pretty much
Um,
it?
yeah, I don't know if you have any questions. Have one or
Sounds
two other
good.
slides, but it's better to answer questions, I guess.
Yeah. We're running a little bit low on time.
Yeah.
If so, if you guys, is there a way to contact you if people have questions?
Yeah, of course. You have my email. I'm gonna put my email here. Sorry. Yeah, that's you. And I'm might be able to answer some questions on the chat, but at some point I'm gonna have to go to sleep. So
Oh
if you
yeah, no
don't find
problem.
if you don't find me on Discord, you can even find me either find me on LinkedIn or by email. So
Yeah, we just
don't
have
hesitate.
to move on to our next workshops, which is
Of
happening
course,
soon. So sorry to cut you off, and
no
also want to
problem.
respect your time.
No problem, of course. Thank
Yeah,
you.
it was a great talk.
Thank you. Thank you very much. Thanks for everyone. And yeah, don't hesitate to reach out.
Yeah, have a nice day. Thank you,
Thank you.
or have
Bye
a nice sleep. Actually.
bye. Yeah, it's much that. Bye.